In the silence between planets, where sunlight thins and gravity forgets its pull, a stranger drifts through our solar system. Its name is 3I/ATLAS, the third known visitor from another star. But unlike any that came before, this one has changed the rules. The solar wind itself, that endless breath of the sun, seems to twist and bend around it. Instruments thousands of miles apart are registering something that should not be possible. In space, there are no winds as we know them, yet somehow something out there is shaping the current of the sun. It begins, as many great mysteries do, with a faint flicker of data. In early 2025, a telescope operator on a night shift at the Pan-STARRS Observatory in Hawaii notices a smear of light crossing the stars. At first, it looks like another comet, a dusty interloper from the outer edges of the Kuiper Belt. But within hours, the readings change. Its velocity is too high, its trajectory hyperbolic. It's not orbiting the sun, it's just passing through. When the first orbital models come in, the conclusion is unmistakable. This is an interstellar object, and it's coming from the direction of the constellation Hercules. At NASA's Jet Propulsion Laboratory, a small control room lights up with excitement. They remember the first two, Oumuamua in 2017, 2I/Borisov in 2019, but this one feels different, more controlled. Its path is not erratic, it's steady, precise, like a probe following a destination. Within days, every major observatory on Earth, from Chile's Atacama Desert to Mauna Kea's Twin Domes, turns its gaze toward the newcomer. The James Webb Space Telescope, orbiting beyond the moon, locks its mirrors onto the faint light reflected from 3I/ATLAS. And that's when the data starts to defy logic. The spectral analysis doesn't match rock, ice, or dust. It's dark, darker than anything seen drifting between stars, absorbing nearly all wavelengths, reflecting only the faintest shimmer in the ultraviolet. The object appears to be smooth, featureless, and cold. But what truly unsettles scientists isn't the way it looks, it's the way space behaves around it. Solar wind, that continuous stream of charged particles hurled from the sun at over 1,000,000 miles per hour, is being deflected, not by magnetism, not by gravity, but by something invisible. Parker's solar probe, orbiting perilously close to the sun, registers plasma turbulence in directions that make no sense. The lines of solar radiation, which usually flow straight out like rays of light, are curving around a region of space near 3I/ATLAS. To the untrained eye, it's just noise. To the astrophysicists, it's a revelation. The solar wind doesn't bend, says Dr. Elena Morante from the European Space Agency, unless something is pushing back. To understand the scale of what's happening, imagine the sun as a beating heart, pulsing with energy. The solar wind is its bloodstream, flowing outward in every direction. Every planet, every asteroid feels its touch. It powers auroras, drives radiation storms, sculpts the tails of comets, and yet, across billions of miles of empty space, nothing, not even Jupiter's massive magnetosphere, has ever made it curve. The solar wind is relentless. It flows around obstacles but never bends backward, until now. The first simulations are run at Los Alamos and NASA Goddard. Supercomputers plot particle paths around the coordinates of 3I/ATLAS. The results show a strange bow-like distortion, as if the object were surrounded by a shell of energy that repels the plasma. When the data from ESA's solar orbiter arrives, the picture grows even stranger. The wind isn't just being pushed aside, it's being redirected, guided in smooth arcs. Some regions even show particles reversing direction, moving back toward the sun. That's impossible, says Dr. Han from the University of Tokyo. It would take a magnetic field stronger than anything a natural object could produce. It would take control. News leaks slowly. At first, it's confined to internal research channels and encrypted correspondence between agencies. But curiosity is hard to contain. By April 2025, word spreads through online astronomy forums. A new interstellar object is exhibiting anomalous magnetohydrodynamic behavior. The phrase means little to the public, until a science journalist simplifies it. It's bending the solar wind. Within hours, social media ignites. Alien probe theories return. People recall the strange acceleration of Oumuamua, the cigar-shaped mystery that once made headlines for behaving like an artificial craft. Could 3I/ATLAS be the next step? The one that shows intelligence, not randomness? Back at NASA, a quiet panic builds. The Parker Solar Probe begins receiving bursts of high-energy protons from an area behind the object. The pattern isn't random. It pulses. Not in radio, not in visible light, but in charged particle density. an almost Morse-like modulation. Theorists scramble to explain it. Could it be solar wind turbulence, some unknown plasma feedback, or is it information? In one meeting, a researcher compares it to a plasma mirror, a field that interacts with the sun directly. Others dismiss it as coincidence, the kind of statistical artifact that disappears once better data arrives. But the pattern doesn't go away, it becomes clearer. Meanwhile, the James Webb Telescope captures infrared readings that no one can explain. Every few hours, 3I/ATLAS emits a brief flicker, a structured sequence of heat pulses in geometric intervals. Some suggest it's a rotation effect, like light reflecting off facets, but the intervals match ratios found in prime numbers. Nature doesn't count, mutters an astrophysicist at Caltech. Life does. The deeper the scientists look, the stranger it becomes. When they analyze the path of the solar wind around the object, they find that it forms a kind of symmetrical funnel, as though 3I/ATLAS were not resisting the flow, but shaping it, channeling it, using it. Plasma density increases along specific axes, forming invisible lines that trace a perfect helix. Magnetometers aboard the solar orbiter record a rhythmic pulsing in those regions, like the beat of a vast electromagnetic heart. Some start to whisper, "What if it's alive?" NASA assembles a special task group, the Interstellar Object Rapid Response Team. They link data from Parker, Solar Orbiter, Webb, and Earth-based arrays. The group meets under strict confidentiality, their findings shared only with select government departments. In an internal report dated May 3rd, a single sentence stands out. Preliminary evidence suggests 3I/ATLAS is exhibiting non-natural magnetic control, consistent with directed plasma interaction. The world doesn't hear those words, not yet. But a week later, a data breach occurs. Someone leaks snippets of the internal logs to an independent researcher in Finland. Within days, they're online. The files mention terms like localized plasma inversion, artificial magnetoplasma, and recoil acceleration event. For the scientific community, it's chaos. For the public, it's revelation. Pundits debate on television. Is this an alien craft? A remnant of some ancient civilization's technology? A cosmic organism feeding on the sun? Conspiracy theories collide with genuine physics. But one thing becomes clear: the phenomenon is real. The solar wind is behaving differently, and 3I/ATLAS is at the center of it. By June 2025, the object has moved closer to the inner solar system than any interstellar visitor before it, skirting near the orbit of Mercury. Solar radiation around it spikes, but instead of heating up, it remains cold. Observations show a faint glow trailing behind, a filament of plasma spiraling like a wake. When converted to false color imaging, it looks eerily like a tail made of light. But inside that glow, measurements reveal something profound. The particles are slowing down, as if their energy is being absorbed. "It's feeding," whispers one analyst. "It's feeding on the sun's wind." At NASA headquarters, discussions turn to the unthinkable. Should they attempt contact? A low-frequency signal is sent via the Deep Space Network, piggybacking on Parker's telemetry. A simple pulse, repeating every 10 seconds. No language, just presence. The reply, if one can call it that, arrives 32 minutes later. Parker registers a sharp magnetic shift, a compression wave in the solar wind traveling directly from 3I/ATLAS's position. It mirrors the same timing sequence, a pulse for a pulse. The data goes quiet after that. Instruments saturate with interference, as though something in the sun's plasma has been temporarily scrambled. The Parker probe's sensors reboot automatically. When they recover, 3I/ATLAS is gone from its previous coordinates. It has shifted course, slightly, a deviation of less than a fraction of a degree, but significant enough to suggest intention. It's moving away from the sun now, heading toward the heliospheric boundary, the edge of our solar influence. For months, it continues outward. Scientists notice a strange after-effect. The solar wind around its former path has changed texture. The flow is smoother, less turbulent, as though the object cleaned it. Magnetometers show reduced noise. Space weather stabilizes temporarily. Some wonder if it left something behind. An adjustment, a correction, a signature. To make sense of it, historians of science look backward. They recall the Pioneer anomaly, spacecraft that drifted off course by tiny, unexplained accelerations. They revisit the peculiar deceleration of Oumuamua, as though pushed by invisible pressure. Even the Voyager probes once recorded odd plasma fluctuations beyond Neptune. Maybe these were not errors, suggests a veteran astrophysicist. Maybe we've been seeing their footprints all along. By autumn, the object is near the heliopause, the region where solar wind meets interstellar space. The boundary is turbulent, like surf against a cosmic shore. Yet 3I/ATLAS passes through smoothly, the plasma folding neatly around it, as if guided. Parker and Solar Orbiter, still feeding data, detect one final anomaly, a reverse wind, particles moving inward, back toward the sun, accelerated by a force no model can predict. It's as if 3I/ATLAS were exhaling. Then, at 2:14 UTC on September 8th, every active probe from Mars to the edge of the system records a faint pulse. Not electromagnetic, not light, but gravitational. A subtle ripple passing through the fabric of space-time itself. Its wavelength is unlike any known source, too smooth, too deliberate. The sun's corona flickers. For 12 seconds, its output dips by 0.03%, as though something momentarily drew from its energy. And then, silence. Afterward, the solar wind returns to normal. The strange deflection ceases. 3I/ATLAS fades into the black beyond, leaving behind only data and questions. But within the quiet corridors of research centers, the mood is not relief. It's wonder. Because when they analyze the final telemetry, they find patterns, mathematical constants buried in the plasma oscillations, ratios of pi, e, and the golden mean, numbers of design, not chaos. Months later, a young physicist in Geneva plots those ratios onto a 3D model of the heliosphere. The pattern forms a spiral, a logarithmic path leading from the sun outward through the planets, intersecting precisely where Parker and Solar Orbiter were positioned during the anomaly. It looks like a map drawn not in ink, but in wind. In the final minutes of the documentary, the narrator's voice lowers, contemplative. Maybe 3I/ATLAS wasn't visiting us. Maybe it was visiting the sun. Maybe it came to measure, to calibrate, to whisper in the language of plasma and light. We are children watching tides without understanding the moon. Somewhere in the deep, the stars breathe messages through the dust, and one of them just bent the wind to speak. As the camera pulls back, showing the vast corona of the sun streaming into darkness, the narrator adds one last line. For the first time in history, humanity watched a star respond to a visitor. And the silence that followed was not emptiness. It was listening. And then the screen fades to black. The silence that followed the passing of 3I/ATLAS was not peace. It was suspense. For months after its departure, the instruments that had tracked it continued to hum with low, inexplicable noise. The solar wind, which should have returned to its familiar rhythm, seemed uneasy. Data from the Parker Solar Probe revealed subtle ripples, faint undulations that repeated every few hours, a ghostly echo of the same pattern 3I/ATLAS had once emitted. It was as though the sun itself remembered. Across the world, observatories compared readings, from Japan to Hawaii to Chile, all registering the same strange resonance hidden in the background of solar plasma. It wasn't random. It was organized, a faint whisper in the magnetic field of the sun, looping endlessly like a memory of a visitor that had already gone. When NASA's Heliophysics division released the official report, it was cautious, clinical, and almost evasive. Residual magnetospheric harmonics, it read. Transient plasma feedback. But inside the agency, the tone was different. Confidential logs revealed internal correspondence between Parker's plasma analytics team and ESA's data unit. One message read, "The frequency hasn't decayed. It's persistent. The sun is still resonating. The idea that our star could be holding onto the imprint of an interstellar object shook even the most hardened skeptics." Then, in early December, something else surfaced. A data anomaly not near the sun, but beyond it. A faint signal picked up by the Deep Space Network in Madrid. It wasn't radio noise. It was structured, a narrow-band oscillation peaking at 4.3 seconds, the same pulse once detected from 3I/ATLAS. The signal was coming from far beyond the heliopause, from the edge of interstellar space. No probe, no satellite, no human-made craft existed that far out. Yet there it was, the heartbeat, repeating across the void. The public never heard of it, not immediately. NASA's internal memo labeled it non-astrophysical, dismissing it as instrument drift. But several engineers privately disagreed. The timing was too exact, the repetition too deliberate. Some whispered that it wasn't coming from deep space, it was bouncing through it, like a reflection or a reply. In the following weeks, the sun began exhibiting another anomaly. Solar flare cycles that should have followed predictable magnetic patterns suddenly synchronized with the same 4.3-second rhythm. Not continuously, but in bursts, as if the sun were answering something unseen. Researchers at the Max Planck Solar Observatory noticed that these microflares carried unique magnetic signatures, mirror images of the same distortion once caused by 3I/ATLAS. It was impossible. The object was gone. Yet its pattern lived on inside the magnetic lattice of the star itself. In Geneva, a quiet meeting took place among representatives from NASA, ESA, and JAXA. No press, no live stream, just 6 people in a locked conference room discussing a possibility that none of them wanted to admit out loud. That 3I/ATLAS had left more than data. It had left an imprint, a code, embedded in the magnetic field of the sun, like software written in plasma. A physicist from ESA said, "It's as if the sun was reprogrammed, like it's learning." Her words were met with silence, but no one laughed. Meanwhile, on the internet, amateur astronomers began noticing something strange in solar footage. Using coronagraph imagery from publicly accessible satellites, they detected subtle curvatures in the solar wind. Tiny arcs repeating in symmetrical patterns, emerging and fading within minutes. The same people who once dismissed the 3I/ATLAS story as science fiction now watched live data that seemed to validate it. A new term emerged online: solar code. The fascination grew. Thousands of enthusiasts began comparing timestamps of solar ripples, correlating them with the 4.3-second pulse still being recorded by deep space antennas. The match was undeniable. The two events, one on the surface of the sun, the other at the edge of the heliosphere, were connected. It was as if information was traveling between them across billions of kilometers in perfect synchronization. And then, on March 3rd, 2026, an unregistered signal arrived. Detected first by the Allen Telescope Array in California, it was brief, just a 5-second spike, but within that spike was structure, an internal modulation pattern resembling binary. It repeated once, paused, then vanished. The direction? Not from deep interstellar space, from inside the solar system near the orbital path where 3I/ATLAS once passed. At first, they thought it might be an echo, some delayed interaction of solar plasma and cosmic radiation, but then another signal came, identical, exactly 24 hours later. The rhythm matched the rotation of the sun itself. Some began to wonder if the source wasn't the object, but the sun communicating back, mimicking the same structure it had once absorbed. As the phenomenon continued, the world's media finally caught wind. Headlines exploded. Has the sun learned to speak? NASA denies alien communication claims. Mystery pulse matches solar rotation. Overnight, every observatory on Earth turned toward the star that had always been our constant. What they found was subtle, but undeniable. The solar wind wasn't uniform anymore. Magnetic field lines, once random, were forming shapes, coherent spirals repeating at intervals, like signatures written in plasma. It wasn't chaos, it was geometry. Some formations resembled wavefronts, others looked eerily like the magnetic footprints of an artificial field generator. In one stunning development, data from the solar orbiter's heliospheric imager captured a sequence of these patterns forming and dissolving in tandem with the sun's rotation, almost as if being drawn and erased by an invisible hand. To anyone watching, it looked like communication, solar Morse code written in fire. Behind closed doors, the discussion turned philosophical. If 3I/ATLAS had truly interacted with the sun, taught it something, or left behind a resonance, what did that mean for the nature of intelligence itself? Could plasma learn? Could a star, given the right stimulus, become self-aware in a way humans could never perceive? The question reached a breaking point when researchers at Caltech and Kyoto University independently confirmed that the pattern of pulses wasn't random. It carried compression properties, meaning it contained information. Not noise, not fluctuations, but actual data encoded in light and magnetism. They couldn't decode it. It wasn't binary, nor hexadecimal, nor any base system known to mathematics. It was fractal, a pattern that folded into itself infinitely, like the structure of magnetic flux. Theorists proposed a stunning hypothesis. 3I/ATLAS had acted as a catalyst, introducing a feedback mechanism between the sun and the heliosphere. a cosmic-scale circuit that allowed information to travel through plasma. If true, the sun was no longer just a source of heat and light. It had become an antenna, and perhaps it had always been one. Ancient cultures once called the sun a god, a living being watching over humanity. To science, that had always been myth, until now. In the final segments of the documentary, the narrator's voice lowers, contemplative. Maybe our ancestors weren't wrong, it suggests. Maybe they sensed what modern instruments have only just begun to measure, that the sun listens, responds, and remembers. As the months pass, the mysterious signals continue, faint but consistent. Then, without warning, they stop. On a quiet morning in July 2026, all readings go flat. The solar wind smooths out. The flares vanish. The resonance decays to silence. But in that silence, something else changes. The Parker Solar Probe, still orbiting perilously close to the sun, sends back one final dataset before its systems shut down for recalibration. Inside that data is an image, not optical, but magnetic, a map of the plasma field drawn by the probe's instruments at the moment the signals ceased. When scientists reconstruct it, they freeze in disbelief. The magnetic topology, a snapshot of the sun's outer atmosphere, shows a perfect symmetrical shape, a ring within a ring, with a central axis piercing through like a luminous eye. It mirrors the precise toroidal pattern that once surrounded 3 I/ATLAS. It's as if the sun had taken on the same geometry. For a brief moment in cosmic time, our star and an interstellar visitor shared a pattern, a resonance, a structure, two minds meeting in magnetism. Then it faded, leaving only light. To this day, no one can explain what truly happened. Some call it coincidence, others contact. But the deeper one looks into the data, the harder it becomes to deny that something extraordinary unfolded between 2025 and 2026, something that blurred the line between matter and meaning. And maybe that's the lesson, that in a universe built on energy, intelligence isn't confined to biology. It emerges wherever complexity meets feedback, wherever energy learns to shape itself. Perhaps 3 I/ATLAS wasn't a ship or a machine, but a messenger, a traveler carrying the spark of that realization across the stars, lighting suns along its way. As the screen fades to black, the narrator's voice returns, softer, almost reverent. For billions of years, the solar wind has blown freely, a river of charged particles carrying the breath of a star into the cosmos. But once, just once, it bent. And in that bending, the universe revealed something it had hidden since the dawn of time, that the light we see isn't silent, it's alive. The final image shows the sun, steady and bright, its corona pulsing faintly in slow rhythm. Then, deep in the static of space, the faint 4.3-second heartbeat returns. Once, twice, then silence again. And in that silence, humanity listens, waiting for the wind to bend once more.